Hello and welcome to What's Bubbling in ZIM. I'm inventor Dan Zen, and in the last few bubblings we've been taking a look at the new ZIM emitter, a particle emitter for flames and fireworks and atoms and who knows. So we dug into the code in the last two, and this is the third and probably final dig into the code for the emitter. So let's do that now. You can go to the ZIM site, ZIMjs.com, and take a look at those particle examples. We're, like I said, digging into the code here for the ZIM particle emitter. We're on ZIM 5, and let's see where we were at. Previously, we had an emitter created. We were emitting either a rectangle or a circle. The circle's over here, and random colors, and we were tracing that and shooting it off to the right-hand side. Whoosh, there goes some particles. Okay, so let's save this and view it in a browser here. This is one way to see where we were at, and there it goes. And we had shifted over the caching rectangle as the very last thing. We were wanting to take a look at this being drawn as lines rather than stamping particles like that. So before we do that, how about we take a peek at where these particles show up in terms of the layers. So if we say layers colon bottom, like that. Oops, sorry, it's just layers quote bottom. By default, they show up at the top. We should put a comma in there. Let's take a look. So now the new ones are showing up at the bottom in behind there. You can also make them show up randomly. It doesn't look very good with all this stuff going on here. Let's just take the trace off for a second. We will slow this down a little bit. How about 0.5? And we will make them go at any angle. We'll take the alpha off because it can confuse us a little bit. So taking the alpha off. All right. So now how about we take a look and refresh here. So now those particles are being made underneath and you kind of can't tell. And so that's sort of nice. It's like particles that have existed forever are now fading out. If you do like it on top, let's just see it on top again. That's the default and that's fine. I mean, but now we can kind of see the particles coming in. Each new particle just poof appears. There's also random, and that's what we did with the flame example. Random. Now some go on top, some go on the bottom, and that just is sort of putting it any layer in there. Alrighty, so I'm going to undo that and pop on into showing you. Good. So our trace is still true. Instead of animating a rectangle and a circle, let's animate a shape. And the way that is done is with a shape configuration object. So we say type colon shape, and that's going to have to be a string. And then we can specify after the string, we can specify the stroke. So we can make that frame dot green, for instance, and the stroke style. Stroke style, and we'll make that 1 pixel. You can also do fill. But what this will do is it will draw the particle into a shape rather than specify the object already. And let's have a look. Oh, do we still have the rotation? Yeah, we still have the rotation on. So those are shooting off to the right. Let's take off the trace shift for now. We might want to come back to that. We will just make it go everywhere. So the angle by default is everywhere. And let's try this again. Now we have these lines being drawn. Oopsies, take a look at that. That was the width issue, so we'll want to bring the width back up to the stage. Oops, the full stage width, like so. And there they go, shooting out to the full stage width. Neat, huh? But what's even neater is when these start curving. So let's take a look and see what happens if we were to add gravity. Gravity, well, gravity is specifically 0 there, so we're going to comment that out, and now gravity will be the default. And hey, we've got hair, we've got fireworks sort of feeling, that kind of thing. Isn't that neat? So they're shooting up, but then being pulled down by gravity, like so. What else to note? Oh, just before I forget, the stroke style in the current CDN version of Create.js, there's a glitch there where the stroke style is being set, like if you tried to set that to 10, it would be set back to 1. So you'll have to move to the next version of Create.js, which is live, but through their through GitHub and stuff like that. So I'll probably start to be able to use the stage GL. We need to use that next version as well. So in the next little while, we'll have probably a CDN version of that next version of Create.js available on the ZIM CDN. But for now, we're going to be drawing with a stroke of 1 anyway. All right, so that was gravity. What if we add some wind? So wind, colon, remember gravity by default pulls down. So wind, it blows left and right, or to the right we'll make it blow. How about we make it blow to the right of 5? And so we'll see what these particles look like when they're affected by the wind. Ooh, isn't that neat? So now it's sort of blowing that way. We can make that sort of blow over the places. But what I want to show you now is a thing called a sink, and a sink attracts particles. So these forces of gravity and the wind are also attracting. You can imagine something over there, but really they're blowing all of the particles evenly at a force of 5, or all pulling them all down at a force of 9.8. By the way, if you have gravity, it's 9.8. That's the same thing, acting down. Now we're going to go back to setting the gravity at 0. And by the way, if we set the gravity at 0 and have wind, then these things, in a sense, are acting like there's a gravity off to the left. And if we were to equate that to gravity, roughly 10 we'll call it, then you'll see that that sort of, oops, something happened. Oh, that's the force that I adjusted, not the wind. So if we had a wind of 10, so with that force being thrown out there, the wind of 5 isn't pulling them back as far. But now what I was wanting to show you is that looks just like our gravity, except gravity was pulling down, but we have the wind blowing to the side. All right, great. Well, we don't want any gravity. Oh, so we don't want any gravity, that'll be 0, and we don't want any wind. And let's just refresh what that looks like again. Should just be particles shooting out. And we're going to introduce this thing called a sink, which will attract these particles. Are you ready? So we build a sink up here. Ooh, yes! Var sink is equal to, and a sink is any object with an X and Y property. So it could just be an object literal with X and Y, but we'll make it visible so that we can see it, and then we'll make it a display object. So that's, for instance, a new ZIM.circle, 20, frame dot pink. How about? And we'll center reg that on the stage. And we will move it a little bit, 0 in the X, and how about minus 200 in the Y? Okay, so let's just see that. There it is up there, and what we want to do is make it so this emitter uses that sink to attract these particles. And so that's in here, we just say sink colon, well, sink. So that's a reference to the object with the X and Y property. And we can say how much of a force as well. So there go those particles. They're being attracted upwards towards the sink. And as a matter of fact, they wrap around. Let's see if we can shift things around a little bit. one is, we'll move this down. So move it down 100 maybe. So we're moving the whole of the emitter down. And we'll move the sync not quite up as much. Oh, down 100. So we're moving it down, well, let's move it down 200. And take a look. So the emitters move down 200 and the sync is here. So just so we can see how it wraps around this a little bit better. You can also see that the shape of, or the width and height of the emitter being stage width, stage heights, not doing very much for us right now because we don't have enough room there. Yet we're not using the caching rectangle down below. So why don't we just shift the caching rectangle up to 200 pixels? So is that what you would have thought of? Remember we did that in the last bubbling. Trace shift Y, we will move it up -200. Like so, and let's see if that works out all right. Save that and refresh. Good, and we're not cutting off here, no. So we've moved it from way down here up 200, and it's now hitting the edge of the stage nicely. Okay, well, that's kind of cool. So the particles are going, and then as they're being attracted, they're being drawn in, and they're even starting to loop around. So let's see if we can adjust that and see what that loop around is doing, because that looks pretty cool. Let's make the interval bigger. So every ½ second, we will bring the sync force. So where do we put the sync? Sync, there it is. Sync force of, how about 30 or something like that. That should attract them more. We'll also make the life of it, instead of 5, we'll go to 10 seconds. So a life of 10 seconds and save that. And let's see what it looks like. Wow, neato mosquito. We're starting to get this atom. And if we shifted things down a little bit more, we could see that even more. What about if we wanted to emit a particle only when we press on it? Well, actually, let's go back there. Well, okay, that's still going. Anyway, we'll emit an atom only when we press on it. To be able to do that, we can say start paused, :true. And so now we're starting the emitter paused. Now let's just see if that works. Paused. And what we'll do is when we press on stage, so stage.on / question mark mouse, stage mouse down, stage mouse down. If you just put a mouse down on the stage, you'll need to mouse down on some shape or something with a fill color. If you use stage mouse down, you can mouse down anywhere on the stage. Of course, you could put a big rectangle as the backing of the stage and then use stage mouse down, but or rectangle mouse down. Anyway, here we are, function, squigglies here. What we'll do is we'll spurt. We'll use the, we'll spurt, so we'll say emitter dot spurt, and we'll spurt one particle. So we save that, and we come back here and refresh. Paused, spurt. Ah, that's like a bit of a hard angle on that one. And there it goes. Ooh, that looks cool. In 10 seconds, and it starts to. We can spurt a couple if we want. Oh, that one went backwards, so now we've got double ones going. Okay, we can spurt. Now, when we spurt like that, the num will affect it. Did we delete the num? Oh, we could spurt 3 particles at a time. Pew! Cool. It had a certain symmetry, didn't it? So that's spurting 3 at a time, but we can also spurt 3 particles here. And then what happens is they'll spurt at the particle interval. So there goes 1, 2, 3. So 1, 2, 3, they shot. Isn't that neat? So you could imagine if we had a bunch of particles going in a line, we could then spurt sort of like a gunshot or a laser type thing. You can also say how long to spurt for. So if we don't say that, we can say interval, or we could just say false here, and the interval, or sorry, not false, null. Null is don't specify a number and instead use an interval, and we'll spurt for one. Lovely. We'll spurt for 1 second. So now 1 second's worth of spurts, and I guess we were probably at every 500 milliseconds. Is that right? We were interval. Yeah, so 1 second spurted 2. So let's drop that down to 20. And then you can see that the spurting will be quite different. So for 1 second, that's just gone off and so-called spurted. You can, let's just back out of that. We'll go there. We'll only spurt 1. I want to show you how we can adjust things, like we can wiggle things. So let's take a look at a wiggler now. Remember that sync that we had there. Oh, by the way, also let me just show you. Right now we've got it, I think, just spurting 1, and there's the sync. You don't need that sync to show up, by the way. You could just say .alp:0. I don't even think we need to add it to the stage, as a matter of fact. But now it will still work, and you just don't see the sync anymore. We'll leave that back at 1 for the moment. Okay, so how do we wiggle this sync? Well, we could do this. Sync.wiggle, and the property that we want to wiggle will be its x, we'll say, and then this is the base amount. So where do we want to start this wiggling? And that is the sync.x, so the current x position of the sync. How much to the left in this case, or minus? How much minus do we want? How about 100? And how much plus do we want? 100. And you can also say in how much time. We'll just choose 1000 milliseconds for the minimum time and the max, which means it's going to wiggle 1000 milliseconds. And there it goes wiggling. So now when we shoot, this thing will be affected by that wiggle, and it's giving us a pretty random. Let's increase the. Should we increase the force or decrease the force? What have we got? We've got a big force on that. We've got a big force. Maybe that's a bit too big. Like it's overshooting. It's pulling it so fast towards it that it's kind of overshooting a bit. So we'll bring that to a 15. We have no force. Oh, we have a force of 5. We can also reduce the force here. And maybe that's what was causing it. And let's take a look. So it's, oh, now I have to shoot. Oh, yeah, there. That's a little bit better. The wiggle force is staying on the stage. Isn't that neat? Look at that. Oh, so cool. I mean, playing with this is just part of the things we're doing, part of the particles. Playing with this thing has just been so much fun. You could set let's go back and randomly, remember how we were making a shape there. If we take the shape and put it within the rest of our stuff. So now we are either doing a shape, or we're doing a rectangle, or we're doing a circle. And so when we emit, it's randomly going to pick one of those. And there goes a circle. Okay, cool. Here goes a rectangle, and so now I'm clicking a bunch of these things, and well, we got some of them. The random color is also appearing in there to make these colors show up at different things. And we've got the wiggler going in there. Now that wiggle, we just made it wiggle in the X. We could, of course, make it wiggle in the Y. Not only that, but we can wiggle the force of the sync, like how much the sync is attracting. And that's what we were doing to make the flame flicker and stuff like that. When you wiggle the force of the sync, you wiggle the emitter, and the property is the sync force. And then you can specify a plus and a minus for that. But we just did the Y. That's going 100 and 100 as well. I don't know, that's so... There's the wiggle. Oh, right, we gotta do this. Now, why did that jump just to right there? Oh, because I said sync X position, we want the sync Y position. And so now it's wiggling around. Oh, but it's just going back and forth at that angle. Why is that? 100 to a negative 100. That shouldn't be doing that. The sync wiggle on both of those. Start at 100, go to the, I would think that it may go kind of all over the place, which I've had happening before, no problem. Maybe let's just look at that again. It seems right now to be going on, oh, it's time-wise maybe. So we want random times of 3, yeah, that's it, okay. We'll bring in some random times and that will make it go all over the place. So save that and view it. There, now we've got it kind of wiggling all over the place. I don't know if that's going to be beneficial for our experiment, but it might be, as these things are chasing that around in curlicues. Look at that. It's neat. And put a couple of these things and have them all chase around in curlicues. We're making a total mess of everything, aren't we? I like that. I like the other one. The one was going at too much of a force, I think, but the one wiggle just looked really good in there, the line drawing wiggle. Woo, cool. All right, and once again, we don't need to see the wiggler, so if we want to do just the drawing, let's comment that out and get just the drawing. Oh, you know, this is great, it's fun, but we got to stop soon, don't we? This has been a bubbling. And so now we're getting just wiggle lines drawn. Wow, whoa. We'll draw a bunch of them. Here we go, following a wiggler around. Is there anything else that we need to look at? How about we just take a peek at the documentations, make sure we didn't miss anything. So we go into the docs and type in Emitter, and we'll F11 that and see, can you read that okay? Oops, where'd we go? The object, we can pass in a bunch of different objects in an array, and that's a ZIMv value, and so it picks from those objects. You can also pass in a function. And the function, for instance, the snowflake maker, we made snowflakes in a function. And should we show you that? Nothing like, okay, let's see if there's anything else to look at. And the very first thing is something to look at. So F11, back out of this. If we go over to the snowflakes, this is in the particle. There, by the way, is this is the object that we're emitting here is an image. So it's the image of the word particles, just a bitmap. And so that's what we're doing there. For the snowflakes, this one right here, each of these snowflakes is uniquely made from a function. It's just overlapping rectangles and triangles. So we'll go into the code here and see if we can see that. Oh boy, look at the size of this stuff here. So we're looking for a function. I'm looking for, there it is, make flake. And it's just making some rectangles, and it's adding them, like it's got a bunch of shapes here, and then we're looping through and we're making shapes based on that stuff. So there's a function to make a snowflake. And take a look, here is where we specify the object right here. So here's our emitter, and we just say object is make flake. And this emitter, or sorry, the function here is one of 3 types of ZIMv values. So here are the ZIMv values. It can be an array of things to pick from. That's what we've been using. A function that returns a value. So now each time it makes a particle, it runs that function to get the particle. Cool, huh? Or a random number, in which case this, that's just a number, so we're not going to use that one. Or a combination or single values. Okay. So good, that's the object. Width and height, that will affect where an object is positioned if we run them, say, along the top. Did we ever show you that? I can't remember, I hope we did. Let's see, when would that have come in? We saw them all shooting out. Did we ever see them all falling down? I think we did. And if not, then go take a look at the There's one of the 6 examples, the last of the 6 examples has a bunch of stuff falling down. Well, snowflakes also were falling down. Width and height also affects the caching rectangle. So it will only, if you're tracing, it will only show up within the width and the height, unless you, as well, you can shift that. Where is it here? The trace shift Y and the trace shift X right there. Okay, so the interval is how often we're sending these things. You can randomize that. You can, that's good. The number. By the way, any of these things as well are properties, so you can adjust them afterwards as properties. When we make snowflakes, for instance, sometimes what we do is every time we go to burst a snowflake, or not snowflake, sorry, fireworks, every time we go to spurt fireworks, we change the number beforehand. And so during that fireworks spurt, it's always 2 at a time, or it's always 3 at a time. And we made an array from that, and so we put 2 and 3 in there a lot, but then we put an 8 in there or something, or 5 in there. So every once in a while, you'd get a firework that would burst many, 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 many. Okay, so those are properties that you can change after. That's the life of something, and here's fade and shrink are 2 things by default. They're set to true, so they'll fade out and shrink during the decay time. So the decay time happens at the end of the life, but you can move the decay time, say, to the beginning of the life. And you might be going, well, why would you do that? Well, if you have trace turned on, the decay, once it's decayed, it won't move anymore. But the rest of the particles in the trace are still seen, or the rest of the sort of the trail of the particles are still seen. And you may want that to stay around for a while. So you can move the decay time to the start, and then what it's made will stay there until the end of the life. So once the life hits, it will disappear, and you can fade out to that end. So a trace fade time will allow you to fade out what was traced. Okay, so take a look at the fireworks for an example of that. There's the shifting, which we've seen before, the angle and the force. The angle, by the way, is, you can pass in a ZIM rand object there to get an angle between things. We saw that. And same with forces. You can pass in a single force, or choose from forces by passing in an array, or you can pass in a ZIM rand object to choose a range of forces. Gravity acts down. If you don't want gravity, just set that to 0. By default, it's 9.8 going down. Wind is by default 0, but you can add wind. You can wiggle the wind if you wanted to. Here's layers. Remember, you can make it, by default it comes out on top, but you can make it come out at the bottom, the new ones, or a mix. Animation. Did we see twirling these circles? Let's just pop back into the code and make sure that we did. Here's our code. Do you see an animation in here? There's an object. Yeah, animations commented out there. So we saw how we could animate things. That could be pulsing things, like making things bigger and smaller, anything, any animation that we want there. Random things, yep, set random properties. Horizontal, vertical, we'll set them along the top or along the left. We saw the sync and the sync force happening. You can cache the individual particles. By default, it's not cached on desktops and laptops and stuff, but mobile it is cached. The events, right, we didn't look at events. You get an event when a particle is emitted. You get an event when the particle starts decaying, or when it does decay, I think, maybe even when it starts decaying, and then when it ends its life. But those events are not turned on unless you set events to true. So if you set events to true, you can receive them. There are also events for when you, what was it, spurt? When you spurt, spew better? Spurt and spew. When you spurt, you get an event, the same type of events when it's decaying and so forth. So that's cool. Take a look at the fireworks example for events. You can start paused, we saw, and pooling. We didn't quite talk about pooling. Pooling means it will reuse the particles. Once it's decayed them, it will reuse them. And that's fine for these, usually for a bunch of circles, it really doesn't matter, and that helps performance. If in the case of fireworks, for instance, we're making unique fireworks each time, and then the fireworks decay. Once the life of one of those fireworks is gone, it will start reusing the same fireworks. And, oh, not fireworks, sorry, snowflakes. Um, yeah, fireworks might also be related, but anyway, I was thinking snowflakes and saying fireworks. Oh, they're so close. Anyway, snowflakes, those unique snowflakes, we don't want to necessarily reuse the same snowflakes after, a couple seconds. So you can set the pooling amount, the pool min right here, pool min, to say 100, and then it will make 100 snowflakes and start reusing those 100 snowflakes. Or just turn pooling off by saying pool : false. All right, wow, that is a final coding here on the emitter. I hope that was fun. We didn't really even look through the emitter examples, but you're always welcome to just go there, take a look through the emitter examples yourself and see, or review all of the things that we've been talking about here in a What's Bubbling at ZIM. I'm Inventor Dan Zen. I hope you've been enjoying this. It's a heck of a lot of fun to play with, and of course, once you start putting images on there, bitmaps on there, rather than just these quickly done shapes, although they're pretty cool too, then you can make even more effects. Looking forward to seeing what you make at ZIMjs.com. Have a great day. Ciao.